Hello and welcome. This is another Khan Academy support video. Specifically, we're going to look at this week's first assignment, the one that's titled Graph from Slope-Intercept Form, like you see on my screen. For this assignment, they're going to give you equations that are in what we call slope-intercept form. This is a particular way to write an equation. I've got some notes up here that just showed up. Slope-intercept form refers to any linear equation that takes this y equals mx plus b. So anytime I see an equation like this where the y is solved, it's all by itself on the left side of the equation, it says y equals some number times x plus or minus some other number, that's what we mean by y equals mx plus b, or slope-intercept form. Not every equation has to be written this way if it's a linear equation, but when they are written this way, we like that. Because if it is in slope-intercept form, the reason we gave it this name is this equation, the m will automatically tell you what the slope is, and the b, in green here, will automatically tell you what the y-intercept is. The y-intercept, or the b, refers to the beginning point for your linear relationship. It describes where will the line begin or start out on the y-axis. M stands for movement, and slope really describes the movement of the graph. It describes the rate of change. It shows us specifically how much the rise is going to be, how much the y will gain compared to the run, how much the x needs to gain to cause that rise. So here for this equation, as we start to create a graph, I always like to start with my y-intercept, this green piece. And I see for our equation over here that the y-intercept is the b, it's that -4 that we see right there. This -4 represents our y-intercept. So if that -4 represents the y-intercept, we'll go ahead and draw an arrow from this -4 to the y-intercept. Then I know that my graph is going to start out on the y-axis at -4. Or when the x value is 0, my y value needs to be -4 for this graph's beginning point. So based on that, I'm going to go ahead and plot a y-intercept right here where you see the 0 and -4 marked in green. That data point right here represents the beginning point for this equation, or the y-intercept for this relationship. And the second thing that I need to know now about this linear relationship is what is the slope? And here the slope is going to be the 2/3, the coefficient of x, that number that's multiplied with x represents the slope for this equation. And the slope tells us the rise over run. Here, if the slope is 2/3, what this equation is telling us is the rise, the y value, will gain 2 units, but you need 3 x's because it's 2/3. So I'm going to rise by 2 or go up by 2 every time I run right by 3. So showing that here, that would look like going up by 2 and going right by 3. That would represent a rise of 2 and a run of 3. So I'm going to go ahead and quickly take this green data point and put it right here, which represents a rise of 2, up by 2, and a run of 3. So now this blue line that I've graphed has a y-intercept of -4, like they've suggested, or they've asked, and it has a slope of 2/3. The y gains 2, +2, as the x gains 3, or runs to the right by 3. We're going to move on to the next question, but throughout this assignment, your big key, they're going to give you an equation in slope-intercept form, in that y equals form, and your job becomes, how do I find the slope and y-intercept, and use that data to go and graph my new line. So here, we see that for this equation, y equals -2x plus 5, I'm going to first identify my y-intercept, and in this case, our y-intercept is that +5 right there. It tells me the y-intercept, or the y value, is going to be going right here, and I'm also going to go ahead and mark up, we'll put that there, 1 second. So I've got a y-intercept of 5, And then I also need to figure out what is the slope for this equation. And I see this -2 here that's multiplied with x represents the slope. If my slope is a whole number, I put it over 1 to make that slope ratio or fraction make sense. A slope of -2 means y will lose 2, or we're going to go down by 2 units every time we move right by 1 or get 1 more x. So I go down by 2, and I'm also going to move right by 1, and then right here, where I'm putting the new dot, this is going to represent my second data point. So again, we went down by 2 and right by 1, and now this graph follows a slope of -2. It climbs down by 2, right by 1, down by 2, right by 1, and it also has this initial value of the +5 that we were looking for. I'll show one more example, but then I believe you're going to be on your own. Okay, here, again, we're going to want to find our y-intercept and our slope, and that's the data points we really need. So the first thing I'm looking for in green is going to be, what is my y-intercept? And here I see this -7. Oh, let me lose the scissor tool. I see this -7. So the y-intercept is going to be right here. When x is 0, y needs a -7 according to this equation. And then the slope is going to be 4/5, that coefficient of x we see here, which tells us the rise will be 4. This graph will go up by 4. And to make the y gain 4, to rise 4, I need 5 more x's, or I need to run 5 to the right. So here I'm going to show from the y-intercept, the beginning point of -7, the y will gain 4 units, up by 4 from -7 to -3. But to gain 4 units for y, that requires 5 x's to make that happen. So I'm going to also move right by 5 units. And then that's going to help me find our new data point right about here. So quickly we'll graph that y-intercept of -7, that slope of up by 4, and then right by 5. And then that shows us the graph y equals 4/5 x minus 7, now graphed out here. The last question will show it very quickly, y equals 4x minus 9. So if I recognize that our, if I recognize, oh, too much again. If I recognize that the y-intercept is at -9 right there, I'm going to go ahead and first plot that y-intercept of -9. And then I also recognize that the slope is this 4 right here, which is really a slope of 4/1. So I'm going to be climbing up by 4 as I climb right by 1. And our new data point goes right here. So start at the y-intercept, up by 4, right by 1. And that gets you to that final graph. So again, big key, identify the y-intercept, plot a point for the y-intercept, then identify the slope and use that slope to go back to the y-intercept and find your next data points for the graph. If you've got any questions, definitely use their videos, their hints and explanations, but also feel free to send me an email and I'm happy to jump on Zoom to help you out if this wasn't too clear. Keep up the great work. Thanks for watching to the end of the video.